All right, guys. Working through this question right here, example 2 says determine the slope of the tangent to the function f of x equals x squared minus 5x minus 6 at the point negative 2 comma 8. Okay, so here's how we do this question over here. I'm going to demo this in Desmos here for you guys. Okay, so looking at what we have over here, we have our function f of x is x squared minus 5x minus 6. It's going to be the red parabola over here. And I've labeled my point here as negative 2 comma 8. So we want to figure out the slope of the tangent over here. Now, what I'm doing over here, I'm calling this point x comma f of x. And so it's a little bit confusing over here. I'm calling it a comma f of a over here because I want to have a slider for a. This program does not like having a slider as an x value, only as an a value or a different variable like that, but not x over here. Okay, so I kind of made a slider for a, but I'm calling this guy x f of x over here. Okay, now what happens I have over here is I'm making a slope calculation. Okay, now the slope calculation is just rise over run. I'm going to go y minus y, f at a minus 8, and then x minus x minus negative 2 is a plus 2 over here. Okay, so this is going to be a slope calculation over here. Okay, so the idea is though, as I change this a value, this point moves, my slope value is changing. Okay, now this blue line we have over here is not a tangent line, it's actually called a secant line. Now a secant line is intersecting with the curve through the point. We're trying to find the point of tangency here, but it's intersecting the curve at another point as well. Okay, so this is a secant line. So this m is the slope of the secant, not the slope of the tangent over here. What I have over here is y minus 8 equals mx plus 2. This is going to be the equation of the line passing through this point. Okay, here's my negative 2 is my x value, 8 is my y value, and then it's using the slope that I've calculated over here. Okay, now the idea is though, if I take this x value and start sliding it closer and closer and closer, this blue line is starting to get closer to being tangent. Now it's not exactly tangent, it's never going to be exactly tangent, but it's going to be getting closer. Okay, now the idea is here though, if we keep sliding this guy closer, I get like a negative 8.9. If I start going this way over here, I get like a negative 9.2. Now the idea that we're trying to get at is like as this x value approaches this value of negative 2, the slope is starting to approach negative 8.6. Okay. Now with calculus, we can kind of describe this mathematically. Now what we're saying is that this x value is approaching this value of negative 2, and we want to calculate what the slope is going to be over here. Okay. So back to our example. Here's how we do this. Our slope calculation is m equals rise over run, okay, which is this guy over here, x squared minus 5x minus 6 minus 8. So this is like my y value minus this y value over my x value minus this x value over here, minus negative 2. Now if I clean this up, this is going to be x squared minus 5x minus 14 over x plus 2. Now what we have over here is this is the slope of the secant line. Okay, now the way we're going to figure out the slope of our tangent, m tangent, is going to equal the limit as x approaches negative 2. Okay, now it's coming back to my picture over here, back to my graph. So this is like this x value over here. So this x value is approaching this x value over here. So as x starts getting closer to negative 2, well, we're going to see that our slope is starting to get close to the value of negative 9, okay? And we're going to kind of just verify this algebraically here. So it's a limit as x approaches negative 2 of our slope calculation, which is this guy over here. Okay, equals the limit as x approaches -2 of x minus 7 times x plus 2. I'm just factoring the top over x plus 2. And this works because x plus 2 over x plus 2 cancels out now. And now we can see we can take this x value, put it in for x here, and we get -2 minus 7, which is -9. Okay, so this is kind of the answer that we got graphically for the one before. Okay. Example number 3 says, determine the slope of the tangent to the curve f of x equals 3 over x at the point where x equals a. Okay, now it's a little bit confusing over here because this is, when we're saying x equals a, this is a very general point. Just saying x could equal any value, I'm going to say except 0, because 0 is a non-permissible value for this guy. So I can make x equal to anything, and we can figure out the slope of the tangent at that point. So here's how we're going to do that. I'm going to do a quick little sketch. And this graph is a hyperbola. We studied this in our rational functions unit in Math 30. This is f of x equals 3 over x. Okay. Now what I'm going to do over here is I'm going to take this point over here, and I'm going to call it a, comma, 3 over a. Okay. Now again, this is some random point over here. Okay. This point could be here, it could be up here, it could be anywhere in the graph. Depending on whatever x value I have here, this is going to be the corresponding point on this graph. Now I'm going to take this point over here, and I'm going to call it x, f of x. Okay. Now what we're doing here is we're going to take the secant line like this and draw the line between them like this. Okay. Now this is the slope of the secant line. Okay. Now again, how do we calculate our slope? Well, we go y minus y over x minus x. Okay. But again, what we have is we have this value of x is going to be approaching this value of a. So I'm going to say m tangent equals the limit as x approaches a of f of x minus f at a over x minus a equals the limit as x approaches a of f of x, which is 3 over x minus 3 over a, that's f at a, over x minus a. Okay. Now, how do we deal with this type of question over here? Well, this is a rational function of the numerator here, 3 of x minus 3 over a. What I'm going to do is I want to be able to simplify the numerator here. So to do this, I'm going to multiply the top times a and the bottom times a. And on the second term, 3 over a, I'm going to multiply times x over x. And this gives me the limit as x approaches a of 3a minus 3x over ax over x minus a. Okay, now what I'm going to do over here, I'm just going to make this x minus a over 1, because I want this to be like a fraction divided by a fraction. Okay, so hopefully that's okay, guys. All I'm doing is I'm multiplying by the reciprocal. 3a minus 3x over ax divided by x minus a over 1. So I'm going to change that to times 1 over x minus a, and that means the x minus a is coming to the bottom. Now what I'm going to do here, 3a minus x, I'm going to factor out a negative 3. The reason why I'm doing a negative 3 is because that gives me a negative a plus x in the numerator. Okay, and now negative a plus x is the same thing as x minus a. These guys can cancel out. And as the limit as x approaches a, so I'm going to put in an a in for my x value is negative 3 over a squared. Okay, so this is going to be the slope of the tangent for any value of a I want. So in other words, if I put a equal to 1, that would be like 1 comma 3 over 1 to be 1 comma 3 would be my point. Negative 3 over 1 squared would be negative 3. That would be the slope of the tangent at that point over there. Okay, hope this guy makes sense. All right, guys, I'm going to take a quick pause in the video over here, and I'm going to start the next one in a moment.